welcome to 3.2, and we're going to talk about slope. Now, in general, and we've kind of already seen slope on some of the lines we looked at in 3.1, but we want to get more specific now and really drill to what slope is. But in general, slope is the steepness of a line. So some lines have, a slope like this. Some lines have a slope like this. Depending on the value of that slope, you get different behaviors, and of course some slopes look like this. Now, of course, when we talk about slope, maybe let's do this. Let's start by saying the variable we're going to use for slope is m, and m can be thought of as, in the most basic sense, rise over run. That's usually one way we talk about slope and learn to think about slope is we calculate the rise over run. But now let's get a little bit more specific. What do we mean by that? Well, we mean change in y divided by the change in x. Now, if you get into a little bit more of your textbook or other math resources, you'll eventually see that condensed down to this. So we have this triangle symbol, which stands for delta, which simply stands for change in. And so again, this is a mathematical way of saying change in y over change in x. And this finally can be broken down into what we'll actually be using, which is this. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we could say where x1, y1 and x2, y2 are any 2 points on a given line. Given line. So as long as you can find 2 points, you can graph a line. We kind of saw that in 3.1. But also, if we have 2 points, we can determine the slope of any line. And again, notice the ordering here. It's the y value of the second point minus the y value of the first point divided by the x value of the second point and the x value of the first point. Now, one thing to say out loud there is that technically the order of your points doesn't matter, but essentially when you choose this to be point 1 and this to be point 2, make sure you're consistent, but you could have said I want this to be my first point and this to be my second point. Like the order left to right doesn't matter, but once you say this is point 1, make sure you then say, okay, x1 and y1, these two values are going to be on the top right and the bottom right, because the 1 point is on the right hand side after the negative. So make sure you're consistent with that 1 point has their coordinates stacked on top on the left side, 1 point has its coordinates stacked on top on the right side, y on top, x on the bottom. If you don't follow that order, the formula doesn't work. And so again, hopefully just seeing this point clearly written out as the first x value, the first y value, etc. Clears up what we mean by this. Right, so again, we know mx plus b. So what's that m? It's the rise over run. What's rise over run? Well, we mean what's your vertical change. That's why we call it rise, because it's moving up and down. What's your run? How far left or right are you going horizontally? Again, we can be more mathematical, and then we can be, I guess I would call it almost practically mathematical, because this is what you'll actually use. Now, I kind of drew out a few different slopes here. A positive slope, a very steep positive slope, and a negative slope. But now let's define those 4 types. So there's positive, which of course, if we had an xy axis, would look something like this. All right, and we would say it moves up as we travel from left to right. All right, so as we move from the left side of this graph to the right side of the graph, my y values were increasing. That's a positive slope. Counteract that with a negative slope, and I'll draw maybe a more steep negative slope. And of course, this moves down, and that's actually the only thing you reverse in this statement. You know, sometimes in math we reverse like all the words, but this time all we're switching is the fact that we're moving down as we travel left to right. And the reason for that is actually kind of interesting, and we'll point this out as we get further into it, but the reason that we only change one part of this is because if I changed the vertical part from up to down, that'd be one negation. And if I change these from right to left, that would be a second negation. And maybe we know this fact in math. If we double negate, well, a double negative actually cancels out to become a positive anyways. So keep that in the back of your head, and we'll show you what that means graphically later on, or explain why that's happening. So there's positive, there's negative. I forgot to write that down. And there's horizontal. And so if you have an XY axis, here's X, here's Y, maybe we have a line that's somewhere up here. Sometimes for lines we use cursive letters to show that's my line, this is the x-axis, this is the y-axis. Now the thing about this is we also refer to this as a zero slope. And the reason for that is as I move left to right, that's kind of the bottom or the other part of this is as we travel left to right, what do I do? As I travel from left to right, what do I do? This time, as I travel left to right, I don't change moving any more vertical in up or down. So, zero slope. I'm not changing my y value. And, of course, that means the last one would be vertical slope. Now, we sometimes refer to this as undefined. And the reason we call this undefined is, well, for what I just said a second ago. If we move from left to right, do I move up or down? If I move from left to right, do I move up or down? If I move from left to right, do I move up or down? Well, in this case, the answer is no. And then finally, well, for a vertical line, if I've got my x, y axis, and I've got another line, again, just to use curly letters, if I've got a line M here, this line doesn't move left or right at all, so it would have an undefined slope. All right. The way I also like to think about it is, if you park your car here, your car would just stay where it is, even if you didn't put the parking brake on. But here, you can't park your car on that because it would just be falling forever. So, I don't know, just a silly way to remember it. But we've got four slopes: positive, negative, zero, and vertical. Now, zero slopes essentially end up being 0 over any number. And for vertical slopes, you end up having any number over 0, and that's a big problem. All right. 0 on top, you can take your calculator out and verify this. 0 over 5 is just 0. 0 over negative 20 is still just 0. But 10 over 0, your calculator will say domain error or something like that. And then if, negative 15 over 0, that'll still spit out that same error. So we've got 4 types of slopes. We've got a slope formula. Let's see how we can start calculating some slopes. And don't mind all the marker and scratching underneath on the kids' table. All right, here we go. So we're going to determine the slope between each of these sets of 2 points. Let's go ahead and dive in. I'm going to say my slope is, and I'm going to call this point 1, and I'm going to call this point 2, just to follow the basic order. And the formula is y2, so there's the y value of my second point, negative 4, minus y1, which would be 2, the y value for my first point, over x2, which is 5, and then careful watch this, minus negative 3, the x value of my first point. So notice the way I'm writing that. You'll see your online homework help you out with that as well. They'll write minus and then parentheses, negative 3, the value you substituted. In fact, this is a phrase I'll start to use throughout the course, but mathematicians are lazy, And what I mean by that is technically whenever I substitute anything, I really should always wrap it in parentheses. It should always be, there's the thing I substituted, there's the thing I substituted, there's the thing I substituted. It's just I, as a mathematician, thought ahead and thought, well, a negative 4 out front doesn't need parentheses. We know the negative applies to that 4. Subtracting a 2, I don't need parentheses around that 2. I don't need to write it. But hopefully you kind of see that's what we're doing here. Is we're substituting. But right here, we shouldn't write negative 3 right next to each other. That's when you'll actually use the parentheses and you should keep it. But anywho, now it's in pen, so it looks like I did it from the beginning, but you watched and saw that we didn't start that way. So I won't write in the parentheses every time, but again, I'm going to say mathematicians try to think ahead and understand when they do or don't need extra writing. And so I already knew I didn't need it on the negative 4, the positive 2 after it's being subtracted, and the 5 out front. But it's nice to write it in to show we were substituting every time. Anyways, let's work this out. On top, I've got negative 4, essentially minus 2, which would be negative 6. On the bottom, I've got 5 minus negative 3, which will double negate and become 5 plus 3, which would be 8. And I can reduce that. That'll be negative 3 over 4. And so I've got a negative slope. Great. All right, let's keep going. Up next, I guess I'll go in order. Up next for my slope here, I'm going to again do y2 minus y1 over x2, it's this one over here on the right, minus x1. Again, it's the same number, but we still want to make sure we, because 10 was on the right and it went on the top left, this 2 should also be on the bottom left. Again, what is a point ends up stacking vertically. So there's the 10 and 2 from this point. Here's the 8 and 2 from this point. And we keep on going. 10 minus 8 is 2. Now 2 minus 2 is 0. And so I definitely have an undefined slope because I just had a number over 0. All right. Up next, let's look at the next one. I've got y2, 14, minus y1, 5, over x2, 4, minus x1, 1. That's going to be, let's see here, 9 over 3. That's going to be a slope of 3. And so we've got a positive slope. Now, just to do it once before we move on, let's show you that what I was kind of saying before is technically it doesn't matter which one you consider to be the first point or the second point as long as you're consistent. Let's show you what I mean by that. So let's say I choose this to be the second point for whatever reason. Well, I would have 5 minus 14, y2 minus y1. Now this is y2, now this is y1. And then that would be over, this is now x2, 1, minus 4 is now x1, if I choose to order it that way. Again, notice that the point values are stacked on top of each other. The 4 and 14 are stacked on the right. The 5 and 1 are stacked on the left. Here it was the opposite, but again, the 4 and 14 were stacked and the 5 and 1 were stacked. We're just switching that order. Let's work that out, though. And the page is kind of sticking up, but 5 minus 14 is negative 9, and 1 minus 4 is negative 3. And hey, look, we've got some double negating. That's still positive 3. So it's kind of interesting, but just know that again, which one you choose to be first or second doesn't technically matter because it will work out the same. You'll end up with either double negatives or, something will end up working out mathematically to where you will get the same answer. All right, just wanted to show that once, but we won't, verify that every time. Up next, let's do again y2 minus y1 over x2 minus x1. Again, see how I need that parentheses there because I'm about to double negate. Now I have 5 minus 5, which is 0, over 3 minus negative 1, which will end up being positive 4. And that's, of course, just 0, so I've got a 0 slope. All right. So we saw one of each of the types of slopes, and now they work themselves out. If you end up with 0 on the bottom, it's undefined. If you end up with 0 on the top, it's, 0. And if it's just a negative value at the end, whether it's a fraction or not, it's a negative slope. And if it's a positive value at the end, whether it's a fraction or not, you've got a positive slope. All right, up next, maybe, we're going to do this a lot more in 3.3, but Let's now look at different forms of lines, and let's remember that there is an equation called y equals mx plus b. We call this slope-intercept form. We'll define it further, but maybe it sticks out in memory. And the idea is if you have something that looks like y equals some number x plus or minus that, because it could be a negative b, some number, then you're in this form and you can easily determine your slope and y-intercept. In this case, the slope would be 7. And the y-intercept, be careful about this, it's not just a single value, it's technically a point. It's the point 0, comma, negative 8. Because if you're on the y-axis, your x-coordinate is 0 and your y-coordinate is what's shown in the equation. So in this case, identifying slope and y-intercept is super easy. And really, now you have everything you need to graph a line because you have a starting place and a slope to use from that starting place. But let's look at the next example. We don't have this slope-intercept form, but you know what we can do? We can do some algebra that we learned in chapter 2 and make this look like y equals mx plus b. How would I do that? Well, really, if you look at this, if you want this to say y equals mx plus b, what you're really saying is I want to isolate y. So I could do that by subtracting the 2x, because that's just a different variable than y that I'm trying to isolate. Now 12 and negative 2x are not like terms, so we can just write them next to each other. And last but not least, I need to divide negative 3. Now, when you divide negative 3, you could either write one big line in negative 3. I think what would be better, because we're trying to have m and b completely separate, is to put all things over negative 3 and see where we go. Well, over here, it looks like we'll have y by itself on the left. Negative 2 over negative 3 is just 2/3 x. And 12 over negative 3 is negative 4. And so now, finally, I know that m is 2/3, and my y-intercept is 0, negative 4. All right. I guess I shouldn't write b. I should technically write y-intercept. Let's see if I made that look good enough. Because, again, b was the thing in the equation, but it tells us the y-intercept. Bear with my pen writing there. So now that we've looked at, how to determine the slope and y-intercept, again, m is really easy to find. It's just, is y by itself? And do you have no parentheses to distribute or do anything with? Then great. You can see your slope. It's in front of the x. And you can see your y-intercept. It's the thing at the end, whether it's positive or negative. So that's super nice, super convenient. And now, using that, the question is, well, how do I use slope to graph things easily? Oops, sorry about that. Great question. Well, with this equation number 7, I've got my slope, I've got my y-intercept. Let's see what I can do to graph this. Well, my y-intercept is 0, 6. So from 0, 0, I go up 1, 2, 3, 4, 5, 6. From there, you can use the slope from any point you know. Usually we always go for the y-intercept because we think it's the easiest, but as long as you know a point, you can apply your slope. Now, I wanted to do this example first because it's going to show up in your homework where sometimes your y-intercept is going to be pretty high up the window, so to speak, of what you can graph. And so technically, to use this slope of 2/5, and now let's go back and review some of those definitions. We said that, whoops, where's that page? Oh yeah. We said that a slope can be referred to as the rise over run. It's kind of in graphing that we refer to it as that. So how am I changing in y? How am I changing in x? So let's look at this example. And let's look at my slope. My slope is 2/5, so it's saying I should move up 2 because that's a positive 2. And I should move right 5 because that's a positive 5. And so on this graph, if I were to go up 1, 2, I'd be up here off the page, so to speak, and then write 1, 2, 3, 4, 5. Now, because this is paper, I can go ahead and just draw this in. But again, this is going to happen sometimes in your online homework. Technically, you couldn't graph this point up here because it's off the page. But here's the thing. You could also use this slope the other way around. You could say, well, wait a minute. To go from here to here, I went up 2, right 5. But now think about it in reverse. To go from here to here, I went down 2, left 5. Well, could I go down 2 and left 5 again? Yes, I could, and I'd end up right here. And you can see that that fits the same pattern of that line. So you can apply your slope, I guess I'd say forwards and backwards. The key there is, notice this, and this is what I meant, my double negating still makes a positive. Here I go up and right, those are two positive motions, but to go backwards I go down and left. And guess what? -2 over -5, moving down and left, still is a positive at the end. Even though I had to move down and left to get the point, the overall graph is still a positive slope. Kind of interesting. All right, let's take a look at the next one. We've got an interesting example here because we have a negative slope and it's a fraction, so this is a very important thing to consider and make sure we understand. My y-intercept's at -1. That's the easy part. Now, what does it mean to have a slope of -3/2? Here's what it means. It means either that negative applies to the numerator or that negative applies to the denominator, but it cannot be both. Why can it not be both? Because if the negative applied to both, that would be a positive slope, right? Double negatives would become positive. So when you've got a negative out front, you can think of it either as moving up to the numerator, and that's what we'll do more so traditionally as mathematicians. We refer to the negative as going to the numerator, but it could also be going to the denominator. It's just we never simplify things and box our answers when a negative's on the bottom. We either transfer it to the top or write it out front, but that is what's going on here. Anyways, what does all that mean? Well, it means, let's first look at the first version where the negative applies to the numerator. From this point, I should be able to go down 3, 1, 2, 3, and then right 2, because that's positive 2. I could use that slope again. I could go down 1, 2, 3, and right 2, and I'm still on the page. You just need 2 points to graph a line, but why not practice using the slope? Now watch this. From here, I could use the slope in the opposite direction. I could say, what if I wanted to go up 3, 1, 2, 3, and then now the negative is on the 2 on the bottom, so left 2, but that still fits the same line that I was forming. Same, I could do it again, up 3, left 2, and there's my line. So that's definitely a negative looking slope. It's going down as it moves from left to right. But again, notice how we did that. We either put the negative to the numerator and said, okay, down 3, right 2, because the 2 is still positive on the bottom, or we think about the negative being on the bottom and move up 3 and then left 2. It's your choice, both work, but again, maybe you don't have space to go both directions on your graph depending on where that y-intercept is, or maybe you do, but those are your options. All right, let's keep going. This next one is a little bit tricky because, of course, well, y isn't isolated, kind of what we just dealt with up above here. So the numbers are a little different. Let's see what happens. I need to get y by itself, so I'll subtract 3x. Those are not like terms, so I'll just put the x term up front because, after all, I'm trying to make it look like mx plus b, so I should put the negative 3x in front so that it's closer to being the mx and then the other number. I then need to divide -2. Again, if I divide -2, just working that out kind of in my head, -3 over -2 is positive 3/2. -8 over -2 ends up being positive 4. So there's my simplified equation. Let's graph that now, though, and we'll go a little bit quicker now. I've got a y-intercept at 1, 2, 3, 4. And I've got a slope where I can go up 3, right 2, up 1, 2, 3, right 2. I could also negate this, which means now I could go -3 and -2, and that still fits the same pattern. Down 3, left 2, and down 3, left 2. Again, as long as you find any two of those, you're good to go. But I would probably just, plot my point here and then go up 3, right 2, and call it a day. But again, just remember, if you can go up and right, you could also go down and left because it becomes the same trend over time. Up next, number 10 is a little bit tricky, but not too much so. They just swapped the order here, but you need to know that, well, hey, I can reorder these and make the positive 3x go first and then the 1 go after. That's totally fine. no big deal. So to do this one really quickly, there's a y-intercept of 1. Oh, but this is new. This time our m is 3. What does that mean? Well, remember that any whole number or any integer is really over 1. So this is going up 1, 2, 3, right 1. Up 1, 2, 3, right 1. I could also go down 3, left 1, down 3, left 1. There's my line. Alright, so again, if your slope just looks like a regular integer or whole number, it's really over 1, so your run would be 1. Alright, last but not least, number 11, another kind of rewrite and then solve. So first step, moving quick, would be to add the 2x, which wouldn't combine with the negative 15. And then, of course, I would divide by 5, which would give me this. 2 divided by 5 doesn't kind of work out, so we just write 2/5. Negative 15 divided by 5 is negative 3. So here's my y-intercept at negative 1, 2, 3. And then I could go up to right 5. Or again, I could go down to left 5. Awesome. So sometimes there's a little bit of getting it to mx plus b in order to graph effectively. And maybe the one other thing we should write about slope, I think this is important, is, let's do one extra statement. As long as you know any point on a line, you can then apply the slope and by apply, that's what we were doing when we were graphing. We were saying, oh, it's 3 over 2, so up 3, right 2, this, that, the other, but it was always from another point I knew. And so far, all we've been doing is finding the y-intercept, but I'm saying it like this to say you don't need the y-intercept to graph, you just need to know a point, and that's going to lead us into 3.3 in a second. You can then apply the slope to find, I'll say, a next point. All right, just one more fun fact there. All right. Well, speaking of which, we're at 3.3 now, and we have 3 equations of a line. Let's go ahead and look at them. There's y equals mx plus b. The advantages of this one are it's easy to graph. Again, m is your slope. B is corresponding essentially to the y-intercept, 0, b. All right, no need to review that one. Let's look at the next one. This one's a little bit funkier looking. There's y minus y1 equals m times x minus x1. Now this is the formula that I exactly am writing down what I wrote down on the last page about. I'm saying as long as you know any point, you can apply a slope to find the next point. Now what I notice here is there's still an m, so that must be my slope. But I also notice that there's an x sub 1 and a y sub 1. I've seen that before. That means there's an x sub 1 and a y sub 1, which is, I'm just going to write a point on the line. We could almost say any point on the line, but they'll give us 1, hence the sub 1, sub 1. Notice what that means, though, is, in this equation, there's a y and an x without any what we call subscripts. There's still a y and an x, and there should be because we're graphing lines after all. So if y equals mx plus b has a y and an x without subscripts, then any other equation we have should also have y's and x's without subscripts somewhere, because that's what you need to have a line. And again, unless you're in the special horizontal vertical case, but we talked about that a little bit in 3.1. Anyways, what's the last equation? It's this, where you have ax plus by equals c. Now, the idea here is we say that a, b, and c are integers, What does that mean? It means no fractions, and a is positive. Now, honestly, the thing about ax plus by equals c is I would almost argue there's not really anything super easy to see about this line. It's not really useful, but problems will sometimes be written in that way. In this class, almost just to give us trouble, but just be aware of that. Now, we're also going to learn how to convert from either one of these to the other form. That can get a little tricky, but let's just start and see what we can do with these three formulas. Again, we have, let's write them down. This is slope intercept. This is point slope, hence any point on the line. And this is either referred to as standard or sometimes general. All right. So let's start using our equations and answer some questions. Find the slope-intercept form when we have a slope of -2 and a y-intercept 0, 2. It's nice that they're specifically saying this is the y-intercept, but you should also understand that because, look, the y-intercept is going to be a 0, b. So even if they said slope-intercept with m equals -2 and the point 0, 2, you should know, or hopefully learn to know, that that means this is the y-intercept because the first coordinate was 0 anyways. Now it's super easy to write a slope-intercept equation when you know the slope and the intercept. So really, that's it. My slope, m, is -2, plug it in. My y-intercept is 2, so plug 2 in at the end. Done. Alright, so when you have the information that corresponds to a given name, it should be pretty easy to plug it in. That's why we give them those names. Up next, slope-intercept with a line, slope-intercept form of a line with the slope and the coordinate of the y-intercept. So different phrasing, same question. So this, again, should be super easy. We just have 2/3 x, and then -4 because it's plus -4, and so we just write that as a negative. Great. Now let's step it up, though. Find the slope-intercept form of a line with a slope of 2, which passes through this point. Now, finally, this is not a y-intercept because it's not 0, something, but also they want the slope-intercept form. Now, there are ways of doing this. Some of us learn how to solve for b. I think you should learn the point-slope form because, again, it just says, hey, do you have some point on the line and do you know the slope? Use this one then. All right. And you do have to memorize all three of these, just, again, so you're aware. The point slope is usually the one we forget about most, but we've probably seen it, and again, just forgotten about it. So let's go through this one. It's y minus the y value of my given point equals m, my slope, which is 2. They said it verbally, not with m. And then x minus the x value of my given point. Now, I've used the point-slope form because I had a point and a slope, but I need to get this to slope-intercept form. Now, again, what slope-intercept form really just means is that y is by itself on the left, and that all your parentheses have been dealt with, or you've distributed everything and gotten everything over to the other side. So let's see what that looks like. In this next step, all I'm going to do is deal with the double negating. Right, so minus negative is positive, and I'm going to deal with the distributing because I don't see parentheses in this formula up here, so I can do the distributive property right now. Awesome. Well, now I'm almost done. To get y by itself, I subtract 2. That's just a number. It doesn't have a variable. So I get y equals 2x minus 14. And that's it. That's all there is to it. Because we started with point slope because I had a point and a slope, but I was able to do some little algebra, do my distributive property, move some stuff over, and now I got the slope-intercept form. All right, we got another one that's a little bit more nasty. That'll be y minus the y value equals the slope, and then x minus the x value of my given point. Again, just notice sometimes they say it verbally, sometimes they kind of say it verbally. Sometimes they kind of cut to some notation here. So it looks like first I got to deal with a double negative. I want to do that before I get to my distributive property. Minus negative is plus. And so my next step now would be to distribute the negative 5/9, which shouldn't be too bad. If I distribute negative 5/9, I'm just going to have, well, negative 5/9 x, and then negative 5/9 because 1 times anything is itself. All right, I just need to add 6 now. So I'm going to move it to the other side, which would be plus 6 over 1, but I'll need to multiply that by 9 over 9 to get a common denominator. Just to spell that out and review it one more time in the middle of all of our other work. That's still negative 5/9, but now 6 times 9 is 54, and then 9 times 1 is 9. So finally we're there. We have y equals negative 5/9 x, and then negative 5 plus 54 is plus 49 over 9. And none of those are like terms. 49 is 7 times 7. 9 doesn't have any 7s in it, so that's actually as simple as it gets. All right, so we can use point slope form, or I guess maybe this is the way to say it. We can have a question that says I want slope intercept, but it's going to take us realizing that I can't get there yet. I need to start with another form of a line that I might have more information in order to use, and then I'll get it into slope intercept form. All right. Up next, we've got some more kind of almost review, and then we're going to learn about how to get to standard form. So let's look at this first one. It says you just have 2 points, and we want to go from just 2 points to an entire line. Now, that's actually not too bad to do. It's going to take a few steps, though. First thing is, I'm going to have to figure out what the slope is if I want to be able to graph a line. So I'm going to use my slope formula, which is, again, y2 minus y1 over x2 minus x1. Notice, again, that the y value 7 and the y value negative 8 are the ones subtracting. Then the x value 5 and the x value 8 are the ones subtracting. I kept the order of if 7 went first, then the 5 is directly underneath it. If the negative 8 then is second, then the positive 8 is underneath it. And let's work this out. That's going to be positive 15 when you double negate that. And then that's going to be negative 3 on the bottom. So it looks like my slope is negative 5. Now I put a box around it, but we're far from being done because all I found is the slope, and I want the slope intercept form. Here's the bummer, though. None of these points are the y-intercept because they're not 0, comma something. So I'm going to have to use the point slope form. Now the point slope form, as I kind of said verbally, is just as long as you know any point on the line. Well, I know 2 points on my line, so I could use this point or this point. It doesn't matter which. I think I'll just use the first point, though, because after all, it said y1 and then m x minus x1. But trust me, you could plug in the 5, 7, and you'd get the same final result. We just don't quite have enough space to practice that at the moment. While working that out, we'll double negate and get positive 8 here on the left. I'll distribute and get negative 5x plus 40 over here. And it looks like I could then subtract the 8, and I get y equals negative 5x plus 32. Now, we haven't talked about this yet, and I felt like I went a little fast here. You should be able to plug in some points and double check your work. I should be able to plug in negative 8. And we did this again in 5.1. Times negative 5 times positive 8 plus 32. And let's see here, that's negative 8, and then that's negative 40 plus 32. And yep, I know that is negative 8. I could also double check that by plugging in 5 and 7. So 7's the y value, and I should be able to plug in 5. And let's see here, that's 7 equals negative 25 plus 32. And yeah, that is 7 plus 7. So I know I found the right line. I know this is my slope intercept form. Now then they say they want standard form, And remember, standard form essentially means the x is first, the y is second, and the numbers on the other side. Oh, but make sure the x is positive. If you think about it like that, then if I start from here, to get the x term to be positive and on the left, well, really, that's the same step. I just need to add 5x to both sides. And actually, if I do that and order it correctly, I'm done. There weren't any fractions. The number in front of x is already positive, and it just goes xy, the number on the other side. So not too bad so far. Some of these can be a little worse, though. Maybe we'll see if the next one is. Similar idea. We've got determined the slope first. 7 minus 18, y2 minus y1, over 6 minus negative 9. And I've got, let's see here, that's negative 11 over, 15. So this one is going to be a nasty one because we definitely have a true fraction here. Let me just make sure that I did that right. 7 minus 18, negative 11, yep. 6 minus negative 9 will become plus. That'll be 15. Yep, this is my slope, but I'm going to have to do a lot of work to get there, to slope intercept. My next step would be plug in a point. I think I'll plug in the second point this time, just for sake of example, and the numbers are a little smaller, so why not? And then I have x minus 6. So again, it's y minus a y value of a point you know equals your slope that you just found, and then x minus an x value of the same point that you chose, I guess, to phrase it that way. Up next, let's work this out. We now have y minus 7 equals, let's do our distributive property, well, negative 11 fifteenths x, and then let's see here, plus, I guess, 66 over 15. But wait a minute, 6 and 15 can cross-reduce to 2 fifths. So 2 times 11 will be 22. And I guess just over 5. Trust me, again, you have a calculator to your aid. You could simply just multiply 6 times 11 and get 66, and then over 15, and then reduce by 3 after the fact. But there you go. Now we're still not done yet because y is not by itself. I need to add 7 to the other side. And for sake of time, and because you can use a calculator, I'm just going to tell you that 7 with a common denominator of 5 would be 35 over 5. And so 35 plus 22 is going to be 57 over 5. All right. Alright, and just for the sake of it, I've gone ahead and opened up a little graphing tool here, and I've graphed negative 918, there it is in red. I've graphed 6, 7, there it is over here. And, one way I could check my work here is I could very carefully plug in that simplified equation, which was negative 11 over 15x, and then plus 57 over 5. And take a look at that. That crosses through both of my points, so I know that I've found the correct equation. Now, there is one important point to make here, and that's that this is a great example of where mx plus b would not be good to use at all to graph, because look at where this y-intercept is. If we actually zoom in, it's, I guess, at 11.4. That's not too bad, but really, who wants to graph 11.4? That's in between the numbers. It's not halfway. If you're really trying to graph that with precision, the y-intercept is not a good way to go. And then you need to remember that when you go, essentially down, when you move down 11 and then right 15, you're counting, 11, but you're counting 11 with, that kind of gap in between them, so to speak. So it'd be a really difficult thing to graph by hand. And that's where point slope is so useful. You don't need to know the y-intercept. See, look at this point right here. It's negative 9, 18, no fractions. Look at this point. It's 6, 7, no fractions. And take a look at how far away these are from one another. You can move, let's see here, vertically down 11, and you can move horizontally positive 15, and that's how you get from one point to another. So not every line is going to cross the y-axis in a nice, neat way. Sometimes these other points are actually nicer than the y-intercept, but you need to learn to work with that formula that utilizes them. Okay, we're not done yet, though. We did part A. We haven't done part B. We need to transfer this into standard form. Now, the key about standard form, let's see here, we phrased it like this, is that A, B, and C are integers. If you don't know what that means, it just means they can be positive or negative, but they cannot be a fraction. Well, they could also be 0. They just can't be fractions. But take a look at what I have. I've got fractions. So we're going to use that strategy that we discovered before, which is we're going to multiply this by the LCD. We're going to multiply this by 15, because that's what both of these denominators can divide cleanly into. And then I won't have any more fractions. Let's see that. So 15 on the left-hand side will just be 15y, because there was just a 1 out front. Now 15 times negative 11 over 15, well, the 15s will cancel out perfectly, and I'll just have negative 11x. Now this one's the bummer, is 15 times 57 over 5. Well, 15 over 5 is 3, but I still have 3 times 57, and I'm going to still need that calculator. 57 times 3 is 171. Gross. All right, now that I have 171, I should be able to add this 11x to the other side. Now the x is positive and it's on the left. I've got my 15y and I've got 171 over here. Once again, general form looks pretty ugly, but that is correct. And let's verify it's correct. Like so. Let's go back to our graphing calculator. Let's type in both equations and make sure they cross at the same, or they kind of overlap with one another. So y equals negative 11 over 15. X plus 57 over 5. And now let's graph our general form. 11x plus 15y equals 171. Take a look at that. If I even just move it to 170, you can see they don't quite line up. But once I go to 171, I get a perfect overlap. So this is actually the exact same line. Kind of interesting that, again, that's what that means on that top section where we wrote those 3 equations. We're saying they can be written different ways. Their numbers can look totally different, but they are graphing the same exact line, actually, which is kind of interesting. And we're really close to being done with 3.3. We just have one other kind of problem prompt you'll be given, which is, hey, I want to pass through some point, and here's this entire other line. We're not going to use all of it. You just need to know that it's either parallel or perpendicular. Now, parallel means same slope. So literally, you just copy the slope from the other equation and you just use it instead. Now, perpendicular means crosses at 90 degrees. All right? So, it's, in other words, the exact opposite. Now, how do you form the exact opposite? Let's look at a few examples. Little chart here. So let's say I have a given slope of 3. What would the perpendicular slope be? Well, another way of finding the perpendicular slope is we find what we call the negative reciprocal, which just means you change the sign and flip the fraction. Now be careful, because a slope of 3 might not look like a fraction, but it is a fraction. It's 3 over 1. So if I negate 3, well, now it's negative because it was positive. And if I flip 3 over 1, I have 1/3. That's my perpendicular slope. All right. Same thing. What if I had negative, let's see here. Well, no, let's say I had, 1 over 7. If I had 1 over 7, then negating 1 over 7 would, well, be negative. And if I flip 1 over 7, that'd be 7 over 1, but I now don't need to write that as a fraction. But usually you'll probably see something like this. If I have negative 3/4, then if I negate that or take the negative away and flip, I now have 4/3. So that's how you find your perpendicular slope. Again, that's really 3/1. Flip it to make 1/3 and put a negative sign because there wasn't one before. If there wasn't a negative sign, put one there. If there was, take it away. Flip your fractions. And again, if it was 1 over something, well, now it's something over 1, and you don't need to write the over 1, but you could. All right, with that being said, once you get a grasp of that, these go by pretty quick. So it's saying, find the equation of a line which passes through a given point and is parallel to, in other words, I'm going to look at this whole line and just say, great, the slope I'll use is -3/2. I don't need that line anymore because I extracted its slope out, and I've got a point. And hey, guess what? If I have a slope and a point, I can use the point slope form, y minus the y value of the point they gave me, equal to the slope that I know. In this case, I know my slope is parallel, so I know what the slope of this line is, so I just copy it. And then x minus x1. All right, with some double negating, I've got that. With some distributing, I've got that. And if I add 2, adding 2 is really adding 4/2. And if I add 2, I'm really adding 4/2 because that's still equal to 2. It just has a common denominator now, which would be -5/2. And we're done. So really, this shouldn't be something that freaks us out a lot. It's just parallel means copy that slope and still use the point they told you about. Because my line, the line I'm trying to figure out, passes through this point. I don't care what points this passes through. I just need this line for its slope. They say parallel. I don't need that 7 at all. It's not going to hold any weight. I just want the slope. All right, one more really quick, and then we're done with 3.3. So find the equation of a line which passes through the point 4, -5, and is perpendicular to 5x. And we want the slope-intercept and standard form. So here we go. This slope's m is 5, which means the perpendicular m would be, think about it for a second, -1/5. All right, let's plug it in. I've got y minus my initial y value equals my perpendicular slope and x minus 4. I need to get that into slope-intercept, so here we go. That's y plus 5 after the double negating. If I use my distributive property, I've got my -1/5 x. I've got my positive 4/5 over here. And then if I subtract 5, right? If I subtract 5, that's really subtracting 25/5 when I make my common denominator. Right? 25/5 is still equal to 5, so this is still minusing 5. But I've got my -1/5 x, and now I've got -21/5. There is my slope-intercept form. To get my general form, all right, I need to get rid of all my fractions, so I need to distribute a 5 to get rid of all denominators. Well, that'll be 5y. And since it's -1/5, that'll just cancel out and be -1x. You don't have to write the 1 in front. Then I multiply the 5 again, it cancels out, and I just have -21. Once again, we're still super close, and I just need to add the x to the other side. Which, bummer, I wanted it to happen in the homework, but it didn't. One thing to be aware of is sometimes this x will be positive on the right, so when you bring it over, it becomes negative. If it becomes negative, just distribute a -1. Just like we multiplied, 5 and eliminated all fractions, distribute a -1 and change the sign of every term on all sides, and then your x can be positive, and you're good to go. All right, I think that's enough for this video. I'll see you in the next one for 3.4 and 3.5.